Picture this. It is a long freezing winter night in New England.
Oh, I know those well.
Yeah, right. So you are sitting in a beautiful historic home in Portland, Maine,
Okay.
and the wind is just absolutely howling outside. There's a brutal coastal nor'easter blowing in right off the Atlantic.
Oh, yeah. Dropping a ton of snow.
Exactly.
Mm.
But inside, you're perfectly comfortable. You've got this traditional fireplace radiating this deep, really cozy heat. The family is gathered around. The dog is asleep on the rug. It is like the ultimate picture of winter security.
It's a very comforting image. I mean, we naturally associate that warm hearth with safety, right?
Yeah.
And shelter from the elements.
Absolutely.
But if we pull back the layers of that house and look just a few feet away, right inside the walls and up above the roofline, that cozy imagery completely vanishes.
That's a totally different story.
It is, because what is actually happening to that chimney structure to provide that heat is a violent physical reality.
And that striking contrast, between the cozy living room and the violence happening inside the walls is our focus today.
Yeah.
We are doing a deep dive into some source material provided by Select Chimney Services out of Portland, Maine.
Right.
And our mission here is to explore the hidden mechanics, the unseen hazards, and the very specific sequence of maintenance required to keep a home heating system safe in a truly unforgiving winter climate.
It's a brutal climate up there.
It really is, because as I read through these technical logs, it becomes super clear that this isn't just about keeping your house warm.
No, not at all. It's about preventing property disasters.
Yeah.
When you strike a match and light that fire, you aren't just generating ambient heat, you're initiating a highly complex chain of chemical and physical reactions.
Right.
And if that entire structural system isn't perfectly maintained, that comforting fire can rapidly transform into a catastrophic threat to the entire house.
Okay, so let's unpack this. What exactly is attacking the chimney? Because reading through these maintenance guides, it sounds like the structure is quite literally under siege from multiple directions.
It is essentially a war on two fronts.
Two fronts, okay.
Yeah. You have the external weather actively trying to tear the masonry apart.
Mm-hmm.
And simultaneously, you have the internal chemistry of the fire creating a highly combustible hidden hazard.
So the climate in Portland, Maine is notorious, so that the outside war part makes total sense.
Oh, yeah.
The sources specifically highlight the high humidity, the salty coastal air, and dramatic freeze-thaw cycles.
Right.
But I always assumed a brick chimney was just like a solid pillar of invincible rock.
How does weather actually destroy something that heavy and that rigid?
Well, to the naked eye, a brick and mortar structure looks completely impenetrable.
Yeah, it looks like a rock.
But on a microscopic level, it behaves much more like a rigid sponge.
A rigid sponge. Yeah, a sponge. Both the brick and the mortar joints are highly porous materials. They're filled with tiny, invisible cracks and voids.
Yeah.
So during the autumn months, Portland gets hit with heavy rainstorms and those coastal nor'easters we talked about.
Right.
The moisture from that weather doesn't just wash over the chimney. It is actively drawn deep into those microscopic spaces.
So the chimney is essentially soaking up the storm.
Exactly. It's absorbing it. But the real damage happens when the sun goes down and the temperature drops.
That's the trigger.
That is the trigger. The temperature plummets below freezing overnight. And we know that when water freezes, it undergoes a physical change, right?
It expands.
Right. It expands by about 9%.
Wow.
Now, imagine that 9% expansion happening inside of thousands of tiny, rigid pores within the brick. You have trapped water turning into ice, expanding, and creating massive hydraulic pressure pushing outward.
So it's literally forcing the bricks apart from the inside out.
Exactly. In the masonry world, this violent separation is actually called spalling.
Spalling. Okay.
Yeah. And over time, as this freeze-thaw cycle repeats, day after day, week after week, it leads to severe structural deterioration.
I can imagine.
The faces of the bricks can actually shatter and pop right off.
Just clop off.
Yeah, just fall off the roof, leaving the softer interior of the brick totally exposed to the next storm.
That is wild. And that explains the vulnerability of the brick itself. But the sources point out that this is specifically complicated in a place like Portland because of the age of the housing stock.
Yes, very much so.
We are talking about a dense concentration of century-old historic homes.
Right, which introduces the variable of the mortar holding those old bricks together.
Okay.
Century-old homes were built using traditional lime-based mortar.
Lime mortar. Not the gray stuff we see today.
Right, not modern Portland cement. Lime mortar behaves entirely differently. It's softer and specifically designed to breathe.
Breathe, like let air through.
Basically, yeah,
Mm.
which theoretically allows that absorbed moisture we were talking about to evaporate and escape out of the joints.
Oh, that makes sense.
But if maintenance is skipped and the surface is compromised, that trapped water aggressively degrades those historic lime joints, literally turning them to dust.
Oh, wow. And I imagine if a well-meaning homeowner tries to patch those breathing lime joints with modern, rigid cement from the hardware store, it just traps the water inside the brick instead.
Oh, it accelerates the destruction exponentially.
Really?
Yeah. The modern cement seals the moisture in, the water freezes, and the entire face of the chimney blows off.
That is a nightmare.
Well-
But the outside of the chimney is acting like a freezing, shattering sponge.
Yes.
But here's where it gets really interesting. Because while that cold destruction is happening on the exterior, the inside of the flue is generating a completely different, completely silent hazard.
The inside war.
Right.
And that war is driven entirely by the chemistry of fire.
Okay, break that down for us.
Well, burning wood is not a clean process.
Uh-huh.
The smoke that goes up your chimney isn't just an empty cloud, right? It's a dense mixture of microscopic particulate matter, water vapor, and unburned volatile gases.
And as those hot gases travel upward, they eventually hit the section of the chimney near the roof,
Exactly.
which is freezing cold because it's fighting that outside war we just talked about.
Yes. That massive temperature differential creates an immediate physical reaction.
Okay.
As those hot, volatile exhaust gases hit the chilled masonry near the top of the structure, a chemical phase change occurs.
A phase change, like steam turning to water.
Similar, yeah. The gases rapidly condense. They transition from a hot vapor back into a solid, coating the inside of the flue with a highly combustible substance called creosote.
Wait, so I could have a literal layer of highly flammable material lining the center of my house right now, and I wouldn't even know it.
Completely hidden from view. You'd have no idea.
That is terrifying.
And the hazard doesn't just sit there. It evolves based on time, temperature, and neglect. The sources from select chimney services actually break this evolution down into 3 distinct stages of accumulation.
Yeah, I'm looking at these 3 stages right now, and stage 1 sounds like the best case scenario.
It is.
It's described as a dusty, flaky layer of soot. It seems like it would just brush away easily with standard professional equipment.
Stage 1 is exactly what you want to find as a professional. It indicates a system that receives regular annual maintenance.
Okay.
The unburned fuel has condensed, but it hasn't had time to bake and harden.
Right.
But if you ignore that dusty layer and keep burning fires all winter, the sustained heat and continuous condensation bake it into stage 2.
And stage 2 is where it starts sounding incredibly difficult to deal with. The sources describe it as a crunchy, tar-like substance. It physically clings to the masonry liner.
Right. It's no longer just resting on the surface. It is chemically adhered to the walls. You can't just run a soft brush over it anymore. Removing stage 2 creosote requires specialized scraping tools and, honestly, significant physical force to dislodge safely.
And if you still don't call a sweep, and you just keep burning fires, you reach stage 3.
The worst one.
This one sounds genuinely terrifying. It's described as a thick, shiny glaze. It looks almost like black glass lining the inside of your chimney.
It is essentially a layer of concentrated hardened fuel.
Oh my gosh.
Yeah. Stage 3 creosote is highly resistant to standard mechanical scraping or wire brushes.
Because it's like glass.
Exactly. In fact, it's so dense that professionals often have to apply targeted chemical treatments to alter its molecular structure.
Wait, really? They have to use chemicals to change the molecules?
Yes. They have to break down that hardened glaze chemically before it can even be physically chiseled out.
So the primary goal of a chimney sweep is to extract every layer of this creosote to guarantee that smoke and deadly carbon monoxide can safely exit the home.
That's the priority. Yes.
But it's not just the chemical buildup they have to worry about. I was actually surprised by the physical blockages the sources mentioned.
Oh, the debris. Yeah.
Yeah. Sweeps in Maine are regularly pulling out bird nests, packed leaves, and heavy twigs that have capped the flue over the summer.
It's very common. And think about the compounding danger there.
Okay.
You have a highly combustible layer of stage 2 or stage 3 creosote lining the walls, and then a bird builds a nest of dry twigs right on top of it.
Oh, that's just a match waiting to be struck.
It's a complete disaster waiting to happen.
Which brings up a huge logical problem for me.
What's that?
Well, if I've got a chimney acting like a wet, shattering sponge on the outside, and it's coated in glass-like tar on the inside that requires aggressive mechanical scraping,
Yeah.
won't the technician just collapse the entire structure by trying to clean it?
It is a precarious situation for sure. Running heavy steel brushes and scrapers through a compromised, freezing-damaged masonry column can easily cause broken terracotta liner tiles to just collapse entirely.
Right. So if I'm the technician, my instinct is to just shove a high-def camera up there immediately to see how bad the cracks are before I start brushing.
And that is a logical instinct, but it's physically impossible.
Why?
You cannot evaluate the condition of mortar joints or the integrity of terracotta liner tiles if they are hidden underneath an inch of black tar.
Ah, I see.
Mm.
You must visually clear the foundation, clean the window, and only then look through the glass.
Exactly.
You can't see the cracks in the glass if it's covered in mud.
That is the exact dilemma, which is why standard safety procedure dictates a very strict sequence of service.
Okay, what's step 1?
Step 1 happens the absolute moment the technician arrives. It's a level 1 visual check.
Okay.
Before any heavy wire brushes are deployed, the professional has to verify the base structure can withstand the physical friction of a cleaning.
That makes sense. So they're not going in blind.
Right. They use a high-powered light to examine the lower flue, check the firebox for loose bricks, and ensure the cast iron damper operates smoothly.
They are establishing a baseline of structural stability,
Yes. And if that checks out, then they move to the actual sweep.
which is immediate hazard removal.
Right. They bring in the brushes, the scrapers, and the HEPA vacuums to physically remove the soot, the creosote, and the summer debris.
Okay. And then once that hazardous material is safely vacuumed away, the freshly cleaned walls finally allow for a true evaluation of the masonry itself.
Yes, the deeper inspection.
Right. And the sources point out that this isn't just the chimney sweeps making up arbitrary rules. There is a strict tier system of evaluations here.
Very strict. These tiers are regulated by the National Fire Protection Association, the NFPA.
The NFPA, okay.
Yeah, and those standards exist because we tend to forget that a fireplace is literally a controlled fire inside a combustible wooden box.
Your house.
Your house. The margin for error is 0.
So we touched on the level 1 inspection, which the text says is the minimum annual requirement. Basically a visual check of accessible portions and combustible clearances. But the level 2 inspection is where the real diagnostic work happens.
Level 2 is the deep dive. This is where the specialized, high-resolution, closed-circuit video camera is passed up the entire length of the flue.
And the text says this specific camera inspection is required during a property sale,
Yeah.
after a major weather event, following a chimney fire, or if you change your fuel type.
Yes.
But what exactly is that camera seeing that a sweep couldn't see just by shining a flashlight up from the bottom?
Well, the human eye simply cannot perceive the microfractures in the middle of a 30-foot dark column.
Fair point.
The camera clearly reveals cracked terracotta tiles, rusted stainless steel liners, and hidden moisture leaks.
And why are those microfractures so dangerous?
To give you context on why that matters, a tiny hairline crack in a terracotta tile might seem insignificant. But during a chimney fire, temperatures inside that flue can exceed 2,000 degrees.
2,000. Oh, wow.
Yeah. That extreme heat will seek out that tiny crack, escape through it, and instantly ignite the combustible wooden framing of the house surrounding the chimney.
So the fire just bypasses the protective liner entirely.
Instantly.
That is terrifying.
Mm-hmm.
But then the text mentions a level 3 inspection. And I have to admit, I thought this was a typo at first.
It sounds like one.
It says level 3 involves partial demolition to access heavily concealed areas. Why on earth would a homeowner consent to their chimney being demolished just to inspect it?
It sounds incredibly extreme, I know, but a level 3 inspection is exceptionally rare.
Okay.
A technician only recommends partial demolition when a level 2 camera evaluation uncovers severe hidden hazards that demand immediate intervention.
So they aren't just breaking bricks to look around.
No.
They already know there is a massive problem, like a collapsed interior wall, and they literally have to break through the exterior masonry to reach it.
Precisely. You're only executing a level 3 inspection when you are trying to prevent a catastrophic property disaster.
An imminent collapse.
Right, an imminent structural collapse or a hidden fire hazard that literally cannot be reached any other way.
Okay, obviously we want to catch these issues long before a technician has to pull out demolition tools.
Definitely.
So how does a homeowner know there is a problem before the sweep arrives for their annual visit?
Yeah.
Because the sources outline some very specific sensory red flags.
Yeah, smell is actually one of your most reliable early warning systems.
Because it indicates what the airflow is doing.
Exactly.
Okay, well, the text mentions 2 specific smells.
Yeah.
First, an acrid or campfire smell lingering in the living space.
Right. If your living room constantly smells like a campfire, especially during the summer or when you aren't actively burning wood, that usually indicates dangerous levels of stage 2 or stage 3 creosote are stuck to your flue walls.
Oh, so you're just smelling the tar.
Exactly. What you are smelling are the volatile compounds slowly off-gassing and dropping back down the chimney into your home.
Yikes. Okay, and the second warning sign is a musty odor.
Which points right back to the freeze-thaw cycle we started with.
The sponge.
The sponge. A musty smell means water is actively entering the porous masonry. The structural sponge is wet and it isn't drying out.
So if you smell either of those, you have to act.
Immediately.
The source material actually breaks down the solutions and the economics of fixing these issues, specifically looking at prices for the year 2026. For professional waterproofing, which applies a specialized sealant to prevent that freeze-thaw damage while still allowing the brick to breathe, it typically costs between $300 and $800.
Yeah. That $300 to $800 range depends on a few critical variables.
Like what?
The overall size of the property, the steepness or pitch of the roof, which dictates how difficult it is for technicians to safely access the structure, and the amount of surface preparation required.
Okay, that makes sense.
But comparing that to the tens of thousands of dollars required for a full masonry rebuild if the chimney shatters,
Oh, yeah?
it is incredibly cheap insurance.
Totally. The text also lists repairing damaged roof flashing, fixing cracked concrete crowns, or replacing missing caps.
Right, addressing those specific vulnerabilities stops attic leaks and dangerous condensation inside the flue.
And if the terracotta liner itself is failing, with those hairline cracks we talked about, the ultimate solution is installing a stainless steel liner.
Yes. A stainless steel liner provides a completely gas-tight, moisture-tight barrier from the firebox all the way up to the roof, permanently sealing off any deadly carbon monoxide leaks.
That sounds like the ultimate fix. Now, whenever we talk about physical home repairs, there is always the temptation to save some money.
Always.
I look at a cracked brick and I think, I could just watch a video, buy some mortar at the hardware store, and fix it myself.
I highly advise against that. The DIY approach to solid fuel heating appliances is incredibly dangerous.
The sources are very explicit about avoiding the DIY trap. Aside from the obvious risk of falling off a roof, why is trying to maintain your own chimney such a bad idea?
Because DIY work almost always masks hidden dangers rather than fixing them.
How so?
Well, first, performing unauthorized or uncertified work on a chimney can entirely void your homeowner's insurance policies.
Oh, wow. I didn't think of that.
Yeah. If you have a house fire and the insurance investigator discovers you tried to patch your own flue with improper materials, your claim can be completely denied.
And the text points out that DIYers will almost certainly use the wrong materials anyway.
Almost always.
We talked earlier about the historic lime-based mortar in Portland. If a homeowner buys modern Portland cement from a big box store and slaps it onto a century-old chimney, they are sealing the moisture inside the brick.
They will completely ruin the breathability of the system.
Right.
Or, inside the firebox, a homeowner might try to patch a crack with regular cement instead of custom refractory mortar, which is specifically engineered to withstand extreme heat.
And what happens to regular cement?
Regular cement will literally shatter the first time you build a hot fire.
Jeez.
Furthermore, you simply lack the diagnostic equipment. You don't have a high-definition closed-circuit camera to see the hairline cracks in the liner.
You're flying blind.
Completely blind.
So what does this all mean? We've covered a massive amount of ground from these service logs. We've gone from the salty, freezing coastal air of Portland, Maine, right down into the microscopic chemical changes of burning wood and the rigid sponge of a brick wall.
It means we have to radically shift how we view this part of our homes.
Yeah. The ultimate takeaway for the listener here is that a chimney is not just a static, heavy tube for smoke to magically exit your house.
Not at all.
It is a highly active, incredibly complex system. It is constantly battling severe thermal shock on the inside and brutal freezing weather on the outside.
And because of that, it requires a strict two-pronged defense.
The sweep and the inspection.
Exactly. The regular sweeps clear the immediate interior danger, the creosote, the blockages, the fire hazard,
Right.
while the high-level inspections secure the structural future of the property, preventing water intrusion and ultimate collapse. They are completely symbiotic. You cannot safely have one without the other.
We spend this time learning how something as natural as wood smoke can chemically condense into a hazardous glass-like tar. And we've explored how completely invisible moisture can freeze and generate enough hydraulic pressure to literally blow solid brick apart from the inside out.
It is silent destruction happening just inches away from where we relax.
It's wild to think about.
It is, and it makes you wonder. I mean, if all of this complex physics and volatile chemistry is happening quietly inside a seemingly solid brick column,
Yeah.
what other invisible silent chemistry is happening right now inside the dark, uninspected voids of our homes while we comfortably sit in our living rooms?